Everybody, it's Tyler here at Space City, checking in with 1698V Power Beans. Last year, world finalists in middle school. Congratulations on that, and we're excited to talk more about their robot here. On a great run so far with event wins. Currently fourth in true skill right now, really high up in skills ranking as well too, and it's all because of this incredible robot they have built here so far. A lot of great stuff going on that we talked about with their Lady Brown and backpack. We talked about how, of course, different aspects of this robot works, all the way through from their intake and how they're utilizing it out of the field. So let's learn more about them coming up here on Pits and Parts. Alex, let's talk about this Lady Brown mech you're utilizing on your robot. Obviously, it's been a popular choice amongst many teams out there. How's this working out for Power Beans?
Yeah, so this has been working out really well for us. We've done a lot of wall sticks in the matches, and one reason behind that is because we designed our Lady Brown to be as versatile as possible. So this is kind of short compared to a lot of other teams that you'll see, and that's because we need to be able to score on the alliance stake and also be able to tip mogos and untip them. So to do this, we have a short arm, right? Which means that we also need a really smooth entry for the rings to go into the polycarb. So our polycarb is very well designed. We've went through a lot of different shapes for this polycarb, and ultimately we've ended up with this. So you can see that our top polycarb is 6 holes long, and we have them connected over here, and our bottom is only 5 holes long. And this allows us for the ring to slide in really smoothly. And you might see that we don't have any mesh over here, and that's because we use these omni rollers and rubber bands to squeeze the ring in.
So overall, it's been gripping great for you and stuff so far?
Yeah, it's been working really well. As you can see, that smooth entry right there, the rubber bands and the omni rollers work really well together to squeeze the ring. And we also catted this before, so we know exactly how high the polycarb needs to be raised up from each other. So we have this one connected directly to our C channel, and then this one with 1-inch spacers. And we found that this is like the exactly perfect length.
What CAD software are you using, by the way?
I'm a beginner. This is my first year in VRC, so I'm using Onshape, but I hope to move to Fusion or Inventor later on.
Very cool. Hey, Richard, speaking about on this Lady Brown here, going into the backpack that you have, you're utilizing some different key positions during the match as well, too. Talk to me more about that.
Yeah, so we found that in order for this backpack to work efficiently, since it has such a small compartment and slot for the ring to fit into, we had to get to that angle perfectly every single time in order to work the most efficiently and intake it into the slot every single time. Now, at first, we tried just brute forcing it in by basically making the arm go up at like 12 volts, which is the max speed, until it reached a certain rotation detected by the motor encoder. But we found that this was really inconsistent sometimes. Like when the motor was overheated or something, it would go to a different distance every time. So we first of all tried using a rotation sensor, which we attached to this axle, which would detect how much the arm rotated and get the perfect angle for it to go in. But we found this was inconsistent as well, as the issue was actually in the arm control itself. So what we did is we developed the arm PID, which would automatically get the arm to this angle, which is about 42 degrees every single time. But the problem was that with this was that sometimes we had a mogo over here and we wanted to intake more rings. So we developed the arm PID to not only go to this angle and then wait for the ring to be intaked here, which is detected by the distance sensor over here. But then after it's detected to be in here, we would lift it up automatically so that we can continue scoring with the mobile goal. So like I'll show you a demonstration right now. So move the arm down and then wait. Move the arm down. All right. Now the arm is automatically going to be lifted up by the driver using the PID, and then this is going to go in, and then it automatically lifts up. Now, the driver did that only pressing 2 buttons, which was the button that lifts the arm into this position and the button that intakes. The reason why we automatically lift it up after the intake, we have to outtake and lift it up, is because now we want to intake more rings, and then we can do that freely while there's a ring here ready to score.
That whole cycle process you have is just so smooth, by the way. Like,
yeah,
well done for putting that all together.
Thank you.
Zichuan, on here too, in order to reset things, I see you got that reset bumper going on there. And then what is this little device here, and how's that functioning for you too?
So that little device, we call it the clip. So what it does is it keeps the ring from falling out from behind. Because like when it's out, sometimes when we get hit, it's just gonna go like that, and that is not good. You want it to stay in, and it also helps us like. We don't have to put mesh here. So then it's like more easily to go into the Lady Brown. No, like this reset, it makes it so that the reset makes it go to this position every single time. So like, let's say I close the code right now, and then when I enter back in, when I try it, it goes up. But then if I reset, then it goes back to that position.
And you're the driver of this robot, right?
Yes.
So, I mean, there's a lot of complex things happening with this, but it just seems like overall, as a driver, like, I think your team has made it as easy as possible for you to make this stuff happen, but the skill that's still required to drive this, when I saw you on the field, is just awesome too. What is, like, for you, what has been your number one focus as a driver in getting ready for matches?
Well, so like when we first have a robot, like in order to drive a robot well, you can't have like many different things you have to press at once, or else your brain's gonna like not be able to process it. So we try to make things simple. Like we only intake with one button, and then we only like raise this with one button, and we only use the logo with one button, and we also only drive with one stick because that's like easier to control for me.
So we talked a lot of great different subsystems of this robot here, but Alex, talk to me more, or Alexander, talk to me more about the intake that you're running through and how it all came together.
First off, notice these little wheels under the intake. So what these do is that when the arm, notice that arm gets here, when we're going to wall stakes, we have the ring here, and what will happen is that the entire center of gravity of the robot will basically be shifting forward, and what that happens is that it might tip basically, and that's what these wheels are for. And notice how they're kind of bent, and the reason for that is basically if they're too close to the ground, they'll really drag on the ground, and then we cause a lot of friction. And this is also why they're small arm wheels in the first place, because when they're on the ground, we don't want them to like cause a ton of friction. And the problem is that it actually collides the intake, because our intake like kind of arm seat here, basically it will go when it's down, it will basically go on top of these wheels, and that causes a whole no end of problems. So we have this basically we basically cut a pneumatic tube and just looped it around. And what this did was that it held the intake over the wheels and just enough so that it wouldn't touch, while also being able to intake wheels relatively easily. Rings.
I didn't know if canted omni wheels would be on my bucket list of robots this year, but that's pretty cool the way you implemented that on there to make sure you're not tipping that sort of. Have you actually had a situation where your robot has tipped and that has saved you yet?
Basically, we had an old design with this same kind of arm, and we kind of basically we moved our wheels around, and the center of gravity was basically just too forward. It hasn't actually happened yet. We just
Gotcha. It's because you got a great driver, right?
Yeah, also because we didn't want to risk actual tip.
For sure. Hey, Lexi, on the back of your robot here, I noticed you do have that polycarb that's used for centering on this mobile goal mech on here. So just talk to me about some of the implementation for that.
So we have these polycarb. It's so that the mobile goal can more smoothly enter into the mechanism. So like as you can see here, I can kind of shift this. It makes sure so that like for example like if I couldn't move this, then the mobile goal could just go like this. I mean this can move, but like it's not gonna happen. Like it doesn't go like this, and then it can get stuck on the side, which can really waste our time during a match. So because this can move, our mobile goal, if it goes in here, then it can just like slide in here, and so that like we can clamp onto the mobile goal, and it allows us to score more easily.
Well, overall, this is a phenomenal robot, by the way, Powerbean. So thank you so much for taking time to tell us more about it. I think there's so much that our teams can be inspired from and learn from what this is as well, too. So, of course, good luck here at Space City. You're having a great run so far. We can't wait to see how you do and throughout the rest of the competition season. Thanks a lot.
Okay, thank you.